So this is sometimes referred to as a peak. Okay, that's referred to as a peak. And this low part is referred to as a trough. The low part is referred to as a trough. Okay. Sometimes another descriptive term for this is a valley. You know, like mountains, right? Mountains have peaks and valleys. Peaks and valleys. And sometimes, as far as waves are concerned, it's often referred to as a crest. A crest. The waves are cresting, that means they are peaking. So crests and troughs, peaks and valleys, these are words that are used to describe this. And this shows that a basic shape is just reproducing itself, right? So whose graph repeats at regular intervals. So after this interval, we have another repetition and another repetition and so on, right? So we usually use graphs like this to represent, to illustrate periodic functions, but they don't specifically always have to be like that. For example, on page 347 of your textbook, on page 347 of your textbook, you can see over here, you can see this graph over here. You can see it's repetitious, right? Because say it starts over here, okay? And it's flat and comes down and goes up again. That's one pattern, because now the same pattern repeats. See, this is the repetition of that. Then it goes down just like this one, and then came up. And this is one complete pattern, and it's repeating. Okay, one complete pattern, and it's repeating. So the pattern is repetitive. Okay, so this is the basic shape of the pattern, right? And if you take this basic shape and slide it, it'll fit on top here exactly, right? So you can see that the pattern is being reproduced. So it doesn't just have to be like the water waves that I drew earlier, right? It doesn't have to be just like those water waves. Are there any other patterns? Let's see, for example, on page 350, right? There are three. You can see this is a periodic function because you can see it's just repetitious, right? You can see this is a periodic function. It's a weird function. It's a weird function, but you can see the pattern, and there the pattern's over, right? The pattern starts here, this little blip, and goes up, comes blips again, and comes down. Now it gets repeated. See, this portion is identical to that, right? And you can see this little part. I hope you can see. So the basic pattern starts from here and ends over there, right? And then if you slide that over, then this piece will fit exactly on top of the second piece, and so on. So visually, you can see it's periodic. You can see this is not periodic because you can see if you take this piece and slide it to the right, it won't fit exactly because these are getting bigger and bigger, right? So this is not periodic, but this is periodic. This is periodic. So from a picture, you can tell, is there a basic shape which by translating it, you can reproduce? See, the basic shape is from here to there, suppose. And if you translate it, this piece will come now here. You can see the two pieces, they're identical. See these two pieces, the red pin and the blue pin, they're identical. So from here to there is one picture, and that same thing now, say it stopped there, right? The same one, say it stops there. See, this portion is exactly the same as this. So you can, just by looking, you can tell whether the graph is periodic. And if the graph is periodic, then the function that created that graph is going to be a periodic function. Okay? So there you can see now. All right, certain other important terminology in periodic functions, right? So in a periodic function, like this, for example, you should be able to have a line that will split the function equally above and below, right? So that piece above and this piece below. See, that piece above is exactly like this. Supposed to be, right? It's just a sketch. So pardon me if it doesn't look exactly like, but you know, that piece is supposed to represent that, which represents that, and this piece is repetitive underneath of here. And if you make another piece, it'll show up underneath here. You put a piece at the back, it'll be underneath here, and so on, right? So this red line which I've drawn is the axis, right? An axis is a line, axis of the curve. So the axis of the curve will split the curve half above, half below. All right. So from the axis, if you the maximum value over there, right, like that one, is referred to as the amplitude. Now, you may have come across some of these words in a science class, you know, when you were doing transverse waves, etc. So, and of course, this height will be the same, right? Because they're identical. Similarly, this depth over here is also the same as that, right? Because it's symmetric. Remember, this cut it in half, symmetrically, half above, half below. So the amplitude, okay? Needless to say, this would be a maximum value and this would be a minimum value, very much like your parabolas, right? Max and mins. Okay, so there's the amplitude, there's the axis of the graph. What else is there to say as far as terminology is concerned? Okay, so let's say the graph, let's say a basic shape starts over there and ends over there. Okay, so this is the basic shape, made up of one crest and one trough. Okay, made up of one crest and one trough. All right, so the gap from here to here should be exactly the same as the gap from here to here, because this is one crest and one trough. Okay, so the graph from here to here represents one complete cycle. Okay, the graph from here to here represents one complete cycle. Okay, so we have one complete cycle. One complete cycle is one piece of the basic shape. That's the basic shape, okay? And that shape gets reproduced over and over again if you keep going, if you keep drawing more pictures, right? That's one complete cycle. Now you can measure the cycle from anywhere you want, right? Okay, so you can start from here, for example. If you say you want your cycle to start from here, that's fine. Then your cycle will end over there, because this point has reached its peak and is ready to come down. This point has reached its peak and is ready to come down. So these 2 points are identical points. And so if the cycle starts here, it ends here. You can start counting wherever you like, right? As long as you go from one point to the next point, which is identical. When I say identical, it means its behavior is the same. It's reached its peak, for example, and it's about to come down. It's about to come down. For example, you could have started counting your cycle from here, then it would end over there, right? Because it's at its lowest point on its way up, lowest point on its way up. So those two points would be identical points, right? We use the word phase. They are in the same phase, P-H-A-S-E, right? So in the same phase. That is, they're behaving exactly the same. The distance between these two points which are in the same phase is called the period. The period is the distance between the two. Just like when you have a timetable, right? On a regular day, you'd have come to school in the morning and you'd have gone to your first period class, first period class. It would last for 75 minutes. Then your class would break and you'd go to the next period, another 75 minutes, and so on. So the period, the gap between them, right? And of course, you come on Tuesday and the same cycle repeats. You follow your timetable. So it's periodic, right? Hence there are periods, first period, second period, and so on, right? So the period is the interval between 2 points which are in the same phase, okay? Or the space required, right? It says whose a function whose graph repeats at regular intervals. So this is the interval that's needed to have one complete cycle. The interval needed to have one complete cycle is called the period, right? So if you start from here, if you start from here and go there, that's one complete cycle. So the space needed, or the interval needed to go from here to there, that interval is called the period. Okay, so period, one complete cycle, crests and troughs and amplitude and axis of the curve. Okay, so now, so let's take a look at some things that, so if you look at page 352 of your textbook, I'll just flash it over here for you. You can see some of the graphs. You can see that's a periodic function, right? Because you can see the pattern. So that pattern starts there and ends over here. That's one complete cycle. And then it starts again. See this portion identical to the where my finger's running here, or the red ink pen, right? See these two are identical, right? So in this picture, you're seeing two complete cycles. That's one cycle and the second cycle. Okay, this is also obviously not periodic, right? This is periodic. This is not periodic because you can see the amplitude is slowly disappearing, right? But you can see that this is periodic, and down the middle would be the axis of the curve, right? This axis of the curve would be somewhere down over here. It's not the x-axis, right? Somewhere down over here is a line that splits it half and half. Okay, you can see that this is periodic also because you can see that little portion. Period's over, right? That's one complete cycle, and it starts again, and so on, right? So I'm going to skip all those ones on page 353 and ask you to just play around with them. And I'm taking a look at, say, so if the graph is given, it's easy to spot, right? If it's periodic or not. So, but now what if a table of values is given? Well, if a table of values is given, you can plot the points and then get the graph and make a decision. Or you can just look for repetition, right? For example, over here, see over here, 5, 6, 7. 5, 6, 7, 5, 6, 7, 5, 6, 7. So that's repeating, right? 5, 6, 7, 5, 6, 7. So that's periodic. Okay, so in a table of values, you can see if the numbers are repeating. If there's a pattern in the numbers as they repeat, then of course, if you plot the points, you will see repetition. So down over here, for example, you can see that this is a periodic function, and what is the period? The period is the time taken for one complete cycle. In this picture, what's the cycle? It looks like it starts here, peaks up and drops down. Then it repeats. See this portion? This portion over there is repeating the red ink pen, and then it's over. Repeat, and it's over. So this looks like one complete cycle. And the period is the interval needed for one complete cycle. So in this case, the period would be 8 minutes, times in minutes, right? So it takes 8 minutes for the cycle to finish, and another 8 minutes, a second cycle, and so on. So you get the period, right? Obviously, you get the maximum, and over here you get the minimum value. Okay. So I was wanting to talk about number 8. So here's question number 8. This is while riding a Ferris wheel, Trevor's height above the ground in terms of time can be represented by this graph. So this graph shows, now you know the Ferris wheel, right? In Wonderland and in other places when they set up attractions, you can go on this wheel, right? Sit in a box, and the wheel takes you round and round. And then after a certain number of rotations, it rides over, and you get off, and somebody else takes your place. So that's the Ferris wheel, right? And of course, our graph shows a particular rider. Her name is Trevor. And as the wheel goes round and round, Trevor's height above the ground keeps changing, right? Because sometimes he's right at the bottom, and then as his box goes to the top, he reaches the peak and then comes down again. And you can see that this is a periodic function. And so fundamental questions that you should be able to ask yourself or answer, what is the period of this function? The period is the time taken or the interval required. Again, this stupid software update. I don't use Apple, so why they quit? So what is the period of this function? So the period is the time taken or the interval required for one complete cycle. You can see if the cycle starts here, then it ends over there. And that's 8 units, and since times in seconds, it takes 8 seconds. So the period of the function is 8 seconds. So it takes 8 seconds to make one complete cycle, right? What does this represent? Now, of course, it's a wheel going round and round, right? So if it's a wheel going round and round, and let's say our wheel starts down over here, right? And the wheel's going round, and Trevor's going up, and then he's coming back down, and one complete rotation's over, and it takes 8 seconds. So basically, the 8 seconds is the time it takes for the Ferris wheel to make one complete rotation, okay? Because Trevor was at the bottom, let's suppose, and now he's back at the bottom again. That's one rotation, right? The wheel's gone around once, so one complete rotation. So that's what that 8 seconds would represent. What is the equation of the axis? Now we want to find the axis, right? So the axis is the line that cuts the graph into 2 parts. So do we have a formula for finding the axis? We probably do. Let me just get back to that sheet I was writing on and get the text out of the way. Right. So how are we going to determine the equation of the axis? We can determine the equation of the axis. Well, let's just suppose, right? Let's just suppose here is. Let's just suppose here is our graph, okay? Let's suppose this is our function. So this is time and this is height or whatever. Now you want to put a line that cuts down the middle, right? So best thing to do is to take one that's going to the top, right? So one that's cut and one that's at the bottom. Okay, so obviously this line gives us the biggest possible height, the maximum, and this line gives us the minimum, right? Now the axis of the curve has to cut this down the middle. So basically to cut down the middle, we're looking for the average, right? The middle between these two numbers. Basically that's the average, don't you agree? Basically that's the average. So we can always find the middle by, well, how do you find the average of two numbers? You add them. So max plus min, you divide by 2, right? That will give us this spot, right? If you know the max and the min, you can get the middle, and the axis will be this line, right? So y is equal to, if I call this y, I'm going to call it a. I call this h, so I'm not writing y, right? So h is equal to, right? So there's the axis of the curve. So you want to find the axis of the curve? You have a very simple formula. Just get the middle. How to find the middle? The easiest way is to take the biggest and the smallest and find the average of those two numbers. That'll take us to the middle, and then that's the line. If this was a y, I would write y is equal to, right? So I'm using h because I wrote h for height. We good? So there's the axis of the curve. So we want to find the axis of this particular curve. So let's say the axis will be down the middle, right? So what's the maximum height? Well, each box is about a 1, right? So that's 1, 2, 3. Okay, so this is a 6, so this must be a 7. So the greatest height is at 7. The lowest is at a 1, right? So the average will be, the axis of the curve will be the average line, which cuts it in half. So that's average between the middle of 7 and 1. Well, that's a 4, right? Because maximum plus minimum. So y is equal to 7 plus 1 divided by 2, right? Max plus min and half. So that's a 4. So y equals 4. Y equals 1, 2, 3, 4. So I'm going to mess up my book for a moment. There. So half above, half below. We get? So I can easily find the equation of the average. What's the maximum? Well, the maximum is the biggest height measured from the axis of the curve, right? That's the maximum. Remember, from the axis of the curve, that's the maximum or the amplitude. Okay, so back to the question, what's the amplitude, right? The amplitude is greatest height, so that's this distance here, correct? Which is 7, take away 4, right? That's this height over here. Or you can count from your 4. 1, 2, 3, 7 minus 4. So we can get the amplitude. What's the range of the function? Well, the range of the function, well, you know, the range of the y value. So this function goes from 0 to whatever number this is. So these are all in ones, right? 1, 2, 3, 4. So this is 22, 23, 24. So the range is, it's time, right? Time going from 0 to 24. That's the range. After 24 seconds, when will Trevor be at the lowest height again? Okay, so now after 24 seconds. So after 24 seconds, well, after 24 seconds, when will Trevor be at his lowest height again? Well, you have a couple of options. Option number one is you could extend the graph, right? So, well, if you extend the graph, what would you get? You'd get this piece and there, right? That's the extension of the graph. So after 24 seconds, when next will Trevor be at his lowest height again? Well, you don't really have to extend the graph because you know this is the lowest point. The next lowest point will really be one period. Think about what I just said, right? From this point to that point, that's one period. That's one complete cycle, and the space is one period. And you know that the period is 8 seconds, right? You know, period is 8 seconds. So 8, then another 8, 16 at lowest point, then another 8, 24. And of course, you can see that this would have to be 24 plus 8, so at 32. So that time equals 32 seconds, Trevor will be at his lowest point. So you don't really have to draw this, right? You can just recognize that if you're at the lowest point, after one period, you will again be at the lowest point. So if you're at the lowest point at 24, then we're just going to add 8 because period is 8 seconds, and it'll take us to 32. So you don't have to actually spoil your picture on your textbook like that, right? At what times is Trevor at the top of the wheel? So Trevor's at the top of the wheel at t equals 4, then again at t equals 12, and again at t equals 20. But that's not it, right? That's not it, because then it just goes on. So at 20, if he's at his highest point, then the next time he'll be at the highest point will be at 28, right? Because if this is the highest point, then the next highest point is one period away, right? One period away. That's the next highest point. But a period is taking 8 seconds. 8 seconds. So if you see over here, 4 plus 8, see? 12 plus 8. No? Then 20, that'll be 20 plus 8. But now it says at what times. So you can't just write. So at what times, right, is the question. So you know the times, as you can see, I'm gonna textbook's in my way. Get the textbook out. So you can see based on the textbook, you can see at 4 seconds, right? At 4 seconds, then again at 4 seconds, and then at 12 seconds, then at 20, then at 28, and then ... right? But you can't give this any answer like that, right? You have to give it as a function. So some equation or relationship, right? So basically, is there a formula that I can use to generate these numbers? Is there a formula I can use? But you do know that it's nothing but plus 8, one rotation, right? Plus 8 and plus 8, where this is after one period. This is after 2 periods, right? Each period is lasting for 8 seconds. This is after 3 periods, and so on. So I can make a formula then, right? Because it's 8 times 2, 8 times 3, but it all starts at 4, right? So at what time? At t equals 4 plus 8n, right? 4 plus 8n. But the first value of n is a 0, so at t equals 4. The next value at n equals 1, 4 plus 8. The next one ends at 2, 16 and 4, 20. The next one ends at 3, 3 is at 24 and 4, 28. So this formula will generate this. But we have to tell the reader what values of n to choose. And you can see that n should be 0, 1, 2, 3, 4, etc. But what are these numbers 0, 1, 2, 3, 4, etc.? What name is given to this set of numbers? What name is given to this set of numbers? because we have numbers like just basically 1, 2, 3, 4, 5, dot, dot, dot. What name is given to this set of numbers? Then we have numbers like 0, 1, 2, 3, 4, -1, -2, -3. We have what name is given to this set of numbers? Now, I have to speak because you're not in a class and you probably don't want to answer, but these were called natural numbers. These were called natural numbers. These were called whole numbers. Whole numbers. These were called natural numbers. And these were called integers. And from our formula, n has to be 0 to get the first term, 1 to get the second, 2 to get the third term, and so on. So n belongs to the set of whole numbers, meaning the reader now knows that n should be 0, 1, 2, 3, 4, etc. So there. So that's how we will say that. And finally, the last part, when will his height be 4 meters between 24 and 30? When will his height be 4 meters between 24 and 30? So between 24 and 30, when will he be at 4? Well, take a look then. Let's get back to our picture. So at 4 meters height, right? So at 4 meters height, so between 24 and 30. So this is 24 at the lowest point. That was 32 at the next lowest point. Remember that? So now between 24 and 30. So between 24 and 30. Well, 30 is somewhere over here, okay? Because this is 32. So you can see at 24, Trevor was on his upward journey and has reached a height of 4, right? Has reached a height of 4. And the question is, what's the clock saying? What's the time showing? Now he'll go past that, and now he's coming down. And again, a little later, he will again be at a height of 4, right? Again be at a height of 4. Question is, what's this time showing? And of course, they said between 0 and 30. So I don't know where 30 is going to show up, but here's 24 at the bottom of the cycle, right? At the bottom of the cycle, then is going up to reach a height of 4. What's that show? What's the clock showing then? Goes up to reach its greatest height of 7. Now it's on a downward journey. Again reaches a height of 4, and then it'll come down to the minimum height, and the cycle will continue. Okay, so let's see. So from here to here, that's one cycle, right? Now, let's take a look. So if from here to here is one cycle, right, then let's break it up into 4 equal parts. Like there's one part, a quarter cycle, another quarter, that means half a cycle, another quarter, that's 3/4 of a cycle, and another quarter making the full cycle. So each piece from here to there, that's a quarter cycle, that's a quarter cycle, that's a quarter cycle, that's a quarter cycle. Now it takes 8 seconds to make one complete cycle. Then it will divide that into 4 equal parts. So 8 divided by 4 is 2. So 2 seconds, it takes 2 seconds to go from the lowest point to that height of 4. 2 seconds more from that height to the greatest height. Another 2 seconds will bring us back to a height of 4, and then another 2 seconds will bring us to our lowest point. So starting from the lowest point, if I add 2 seconds, I'll get to that height, right? So let's come here. We were at the lowest point, right? At time equals 24. 2 seconds later, I should be there. So this time should be 26. What do you think? 26, because 24 plus 2, all right? Then this one is 28, right? This is 28. Then 2 seconds later, I'll be there at 30. So and then 2 seconds later, I'll be down to 32, at 32 right here. So that seems to fit nicely. And so when will its height be for between 24 and 30? So between 24 and 30. I want to say that between 24 and 30, I think that 24 and 30 should not count. What do you think? Because it's between these two numbers. Because at 26, he's got a height of 4. At 30, again, he's got a height of 4. So I'm thinking the way the question is phrased, height of 4 between 24 and 30. So any answer between this number and that number. So I think I don't want to count that, right? Because at 30, but if it says between 24 and 30, it means more than 24 but less than 30. That's the way I interpret it, between 24 and 30, right? Numbers between 24 and 30 do not count the 24, do not count 30. So I think there should be only one answer of 26, right? But I don't know. I don't believe that 30 should be included in the answer. But I hope you understand how I'm getting those answers, right? Because each is a quarter cycle. A quarter cycle lasts for 2 seconds. So from 24 plus 2 seconds later, I'll be at that height. Another 2 seconds later, I'll be up there, which is up at 28. So 24 plus 2, 26, plus 2, 28, plus 2, 30, and then plus 2, 32 to bring us back to the bottom. Okay, everybody okay? So I think that's okay. So a quick look at question 11. We got a few minutes more to finish off question 11. So it says Maria's bicycle wheel has a diameter of 64 centimeters. As she rides at a speed of 21.6 kilometers per hour, she picks up a stone in her tire. Draw a graph that shows the stone's height above the ground as she continues to ride at this speed for 2 seconds more. Good God. So that's 21.6 kilometers per hour. So I got to change that to meters per second, right? Or maybe even centimeters per second, right? Because this is diameters in centimeters. So 21.6 kilometers per hour. Goodness gracious me. Okay, so grab a sheet of paper, put the textbook out of the way. So it's the graph that I'm more interested in, other than the other details. But we got to include that also. So 21.6 kilometers per hour. So 21.6 kilometers times 1,000, that goes to meters. Times it by 100, that makes it in seconds, right? So this is kilometers, now to meters, now to centimeters, and this is now to minutes, right? Now to minutes, and now to seconds. So this is in centimeters per second. Okay, this is centimeters per second. So 1 second she rides so much, right? And she's riding for 2 seconds more. She's riding for 2 seconds more. So let's take a look at the graph, what the graph's saying so far, and then so let's say this is time, right? This is time, and this is the height of the stone. Now there's the wheel. Okay, visualize now. This is the wheel over here. Okay, and so the wheel picks up a stone, and as the wheel goes round, the stone goes up and down, right? The stone goes up and down. Now, think about what I'm going to say. By the time the wheel makes one rotation, let's say the stone is on the ground when the wheel picks up the stone, right? When this part of the wheel, which is the circumference, when it fits over here, when the circumference fits over here, because as the wheel turns, every part of this wheel has to sooner or later come to the ground, right? So imagine if the wheel's moving this way, so then these parts are coming to the ground and the stone is going up. By the time the wheel makes half a turn, the stone will be on top. And by the time the wheel makes the second half of the turn, the stone will be back at the bottom. So by the time the wheel makes one rotation, every part of this tire has reached the ground. So this part over here is nothing but this circumference, right? That's the circumference. The diameter of this is 2 pi r, right? Circumference of the circumference one is 2 pi r, or 2 r's makes a diameter, so that's pi d, right? That's pi d. And so if the diameter is 64, so if this is 0, then the circumference is this distance over here, and that's 64 pi. So that's 64 pi. So by the time the cycle makes one rotation, this part of the wheel, which was there, is now over here. And of course, whatever this diameter is, the stone can't go higher than that line, right? So what's the stone going to do? The stone's going to slowly climb. By the time half the cycle is finished, the stone's right on top there. And then the second half by the time it finishes off the rotation, the stone is now there. So this is what the graph is going to look like for one complete cycle, one rotation, and then it'll repeat. So that's 64, so that's 128 pi. So this is at 32 pi. What do you think? Half this period. That's the period, right? And this is 16 pi, a quarter cycle. So like, here's the axis of the curve. Quarter cycles, half the cycles, 3/4, full cycle. Then it repeats again, right? It repeats again. So quarter cycle, half cycle, 3/4, full cycle, and so on. And so now the question is, how many rotations? This is for each rotation of the wheel, right? And so how many rotations will the wheel make? Well, that's a nuisance of a calculation, because the wheel is turning at this speed, right? So many centimeters, it will travel so many centimeters in 1 second. She's riding for 2 more seconds, right? So she gets the stone in a wheel and she rides for 2 seconds. So 2 seconds. So for 2 seconds, that's 21.6 times 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 60 times 60. This is centimeters in 1 second times 2. So this is the total distance, and all we have to do is find that distance and find it over here to decide how many rotations will be completed. But this is basically what the shape's going to be, right? For each rotation of the wheel. Now these numbers are ugly, so I'm not going to even waste my energies trying to figure out how many rotations. You can do that calculation because you can convert these into decimals, right? You can convert these into decimals, and this is a decimal, and then you can decide how many, like in 2 seconds, will she have completed 1 rotation? Is she going that fast that in 2 seconds she'll get 1 complete rotation? Or maybe 2 rotations, or maybe 3, or maybe 3.5? I really don't care. But you understand what's happening to the picture, right? There's a stone. As the wheel makes each rotation, the wheel turns, stone's back on the ground. And then up it goes, like the Ferris wheel, right? Just like the Ferris wheel, same type of idea, okay? Except that I am not going to spend time trying to figure out how many rotations, because you can get a decimal version and you can see where that decimal fits. You can put decimals over here, and then you can see whether we need 1 rotation, 2 rotations, or more than that. So the idea is just basically to get the graph. And this is what the graph's going to look like for each rotation of the wheel. And I'm not even caring about how many spins it takes, because every spin it takes will give you one of those pictures, right? Okay, so that's it. So now that you have the basic foundation, you can play around with 6.1. And tomorrow I'll take a look at 6.2 and 6.3, which will basically do pretty much the same kind of things. So what you need to do is look over the terminology. So look at the worked examples from 6.1 and understand the terminology and be ready to use that when you're doing your communication type of questions. Okay. Right, we'll stop over there for today. We've already gone past your time, so we'll say bye and we'll catch up again tomorrow. But please just read up out of curiosity 6.1, okay, so that you know what we're talking about as we proceed. Okay then, take care, guys, and